Thank you. Now, we'll continue. Okay. Can you just... Now, listen. Come on, sit down. So, come on guys, I'm waiting here. Now, come on. Okay, fine. I just heard sound in this direction. Guys, I'm waiting to start here. I'm going to wait till I have... Yeah, we will see which group now does better at the end of the year. Are we ready over here? Yeah. So, I left my writing pad at home, so it just means I'll have to just type everything up, but I think it'll work okay. I was using this earlier. Okay, so we have to have a look at here. Oh, hang on. It just takes a sec. Can you see that size of font?
Yeah.
That's okay, isn't it? Yeah, alright. So we're having... Please. Thank you. We're having a look at arithmetic progression, or as it's often just abbreviated as just AP for short then. So arithmetic is like the word arithmetic, which means to add. So an example of an arithmetic sequence would be something like 2, 4, 6, 8, 10, etc., etc. This is an arithmetic sequence because, well, the rule is arithmetic. Each time I add 2 to get the next number. So what makes it arithmetic is the fact that the rule is you add the same number each time. Okay? So this is like the sort of basic definition of arithmetic. So we can try and put a formula together for arithmetic. So I could say something like, if we use some letters, so we'll say let A equal the first term, and then D. Now I wonder if anyone knows the name of the D. So the D is what we'll call the thing you add each time. Yeah, common difference. Oh, actually, we'll need some new lines, won't we? Oh, no. No. Sorry, I didn't realize we weren't going on new lines. There now. Does anyone know the name of the D? Very good. And this is the number that you add each time, the common difference. Okay. So, for example, if I had some sequence that started at A, what would be the next term? So if the first one was A, what would be next? A plus D, yeah. So you could start off with A, and then the next be A plus D. What would be next after that? Yeah, 2D, and then A plus 3D. And like, yes. And so forth, and so forth. So if we wanted to try and figure out a general formula, do you notice here, the first term has no D in it. The second term has one D in it, and then the third one has 2, and the fourth one has 3 of them. So in general, if I wanted the nth term, A plus n minus 1D, yeah, n minus 1D. So it'll look like this. Un equals A plus n minus 1D. This is our first formula. There's 2 formulas we're going to have a look at today. So the first one, first formula.
So the other formula is...
Yeah, which one? Some people might actually know which is the other one.
The G?
No, just looking at AP today. I will see it in a few minutes anyway. So can you write down the first formula here? Okay. Do you have that written down? Let's continue now. So the next thing I'll have a look at. Right, so here's the sequence. So my question is, what is the A and D here? So I have the sequence 0, 4, 8. What is the A and what is the D?
0.
Yeah, so the answer is the A is 0 and the D?
4.
Yeah, because each time I'm adding on 4. Yeah, so I have A is 0 and D is blank, it's 4. I think that's easy enough to start with. So the A is the first term and the D is what you have to add each time. So nothing too special there. Okay, let's make it a little bit harder now. So let's have a look at another example. New line, example 2. Okay.
Is this also recording?
Yeah. Because I don't have my writing pad with me, so I'll just have to type. Okay, what's my next example? Let's see. Find the nth term in the sequence -9, -14, -19, and etc. Okay, oh, sorry, I'll have to scroll down a bit there. Right, so this one here, I want you to find the nth term in this sequence. So in other words, I want you to find me a formula that can tell me the term if I provide you the n. So it's literally using the only formula that I've given you so far. So let's have a look here. Yeah, so it's un equals a plus n minus 1 d. And what's the a here? -9. And what's the d? -5, yeah. Because each time what's happening is I'm adding a -5. I'm going to delete the stuff from earlier because I need to make a bit more space. I'm sure you have it. Okay. Can you see everything? Yeah, there we go. It's okay, you can see it all? Okay, so what should I do next now if I want to clean this up a little bit? Yeah, simplify by expanding. So if I expand this, I'll get -9 minus 5n plus 5, isn't it? Which is -4 minus 5n. So let's just have a look at that. Yeah, so this is my final answer down the end here. Let me just put that on a new line for you.
What if we don't have the sequence didn't give us the first one?
Good, yeah, I'll have to give you the first one, otherwise that would be quite difficult then, yeah. We will look at some questions in a moment where we have to figure out what the a is. So let's check if this formula works. So if I put n as 1, what do I get here? -9, which I should. And if I put n as 2, I'll get -14, which I do. So the formula appears to work then. Okay, next one now, when you're ready. Example 3. So what we'll have a look at now is not quite working out the a, but working out the n. So that is how many terms are in the sequence, and let me just see which one. We'll do so, yeah, 9. Okay. Whoa. 9. Let's see if that fixes it. Yes. 9, 18, 27. Dot, 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 all the way up to 126. Okay, so this one here, you can see what the A is, you can see what the D is, but what I don't tell you is how many terms you have. And you can't count, because I put a dot, 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 so you don't know how many there are.
Why do you have 2 18s?
Do I? Oh yeah, sorry. That would be a very weird arithmetic sequence, wouldn't it? Yeah, 9, 18, 27, dot, 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 126. So I want to know how many terms there are. Well, I know there's at least 4. Because I have 4 numbers. Is it?
You basically put in the formula.
Yeah.
You have the A, you have the D, and just replace. You solve for
Yeah, so what is the A here?
the A is 9. You touch 9.
Yeah, and the D?
It's
I think it's also 9.
Yeah.
So I have my A and I have my D, but I don't know is the N. So how can I figure out the N here?
You replace.
I put in the formula. So in my formula, UN equals A plus N minus 1D. A plus N minus 1D. I know the A and I know the D. I don't know the N, that's fine. But what about my UN? What's the A here?
The A is
9. And the D? 9, fine. The UN?
126.
Yeah. Because you want to figure out what the N is when you're at 126.
Yeah. It's 126 over 9.
Let's have a look here. Let me just make a bit more space. Okay, so let's fill in the numbers. Right, what do I put in for UN? 126. And then my A is 9 and my D is 9. Yeah.
So N is 126 over 9.
What happens if the D is not the same for each number? Like what are you doing?
Oh, no. A constant D is all we're looking at today. Yeah. There is sequences where the D changes, but that's not something we'll look at. Yeah. Okay, so what should I do next? I think I'll just yeah, I could expand, couldn't I?
You do, 9 and 9 are gonna go. So you're gonna have 9 and is equal to 126.
I think I'll just take the 9 to the left first.
Okay.
Not that it matters too much.
9 is gonna go.
It's gonna be the same.
Yeah. So 126 minus 9. What's that?
117.
117. Yeah. And then after I subtract the 9, what should I do next?
Add a 9.
Not add a 9.
Because you expand and then you're gonna add it.
Not that. There's something easier to do. 117, isn't it? Yeah. There's no need to expand the bracket. What do I do next? Divide by 9. Yeah. So there's no need to expand the bracket. I'll just divide by 9. So what is 117 divided by 9, please?
13.
I'm hearing 13 and 14. It is
13 and a half.
13. Okay. So I'll divide by 9 and put in the 13 then. Okay. So this is I understand now why people were saying 14. So if 13 equals n minus 1, then what's n? 14 then. Yeah. Okay. So the n is 14 then to finish with.
Does it matter if you expand it first though?
No, same answer. Oh, but what do you mean by matters though? It'll take more time.
Yeah.
No, in contrary.
No, it's actually.
You have like 5 lines, I have like 3.
Because the N and the 9 and the 9 cancel each other.
Yeah, 9 and 9 are gonna go. It's here.
I could. Okay. Whatever. Fine. Whatever. I can put in more steps because I have the keyboard. I can copy and paste. So I'm being relaxed about the number of steps now. When I handwrite, I'll care. Right, have we got this example? Yeah. Can I delete it? I need to make some space.
Yeah.
Well, I'll delete at least example 2. You don't need to be seeing that still. Okay, so now on to example 4. Okay, so
Are we gonna do geometric and surrounding too?
yeah, I think so. We should do, yeah. Example 4. The 7th term of an AP is minus 13, and the 17th term is flip. This is why I don't like keyboards. Let's start again. The 7th term of an AP is, what did I say? Minus 13, and the 17th term is minus 23. Find A and D. Right, see, that looks okay. Yeah, the 7th term is minus 13 and the 17th term is minus 23. Find the A and the D. So this one's interesting. I've only given you 2 terms and they're not even neighbouring terms. One is the 7th term and the other is the 17th term. And I want to know, try not to take out somebody's eye, please.
You want to find D?
Yeah, well, what should I do first here? What should be my first thing I do?
Write out the formula, which is A plus.
Yeah, write out the formula. Yeah, and then find D will be the easiest one to find. So let's write out the formula. What's my first formula there? If I look at the 7th term is minus 13, how could I write that as an equation? A plus 60 equals minus 13 because it's n minus 1. So this is me saying that the 7th term is minus 13.
Take it all to one side, maybe?
Not just yet, no, not just yet. Can I remove example 3? Get it out of my way. Yeah.
Why A plus 60? Because it's the 7th term.
Yeah.
And n minus 1.
Yeah, the formula is A plus n minus 1. So the 7th term is A plus 60.
And A plus.
Yeah, and now we can make the other equation. So what's the other one saying?
A plus 16B is equal to.
Yeah, and that's it. Just simultaneously solve them, isn't it?
Equate A and find B.
Well, what's the easiest way? What's the easiest way to solve this part? Elimination, yeah. I'll just minus them.
Yeah.
So the second equation minus the first equation.
Yeah.
So what? 10d equal to minus 10, is it?
Yeah.
Okay, let's just get that back up.
So D is equal
Yeah.
to
So d equals minus 1. Yeah.
Base for A.
And then we get the A. Easy peasy. Easy peasy. Okay, so what did you work out for the A then? Right. What?
6 minus 16d is minus 10d, minus 10. Otherwise, you have to make it 10d equals 1.
Wait, what?
A, hang on, well, no, let's check. A minus A, gone.
Yeah.
16 minus 6, 10. Minus 23 minus 13. Minus 10. I think that's okay, yeah? Yeah. And so you get the A is minus 7 if D is minus 1.
What's the time?
I'll check that now for you.
Wait, 6 minus 16 is
18 minutes. Guys, what's wrong? Is this right, isn't it, or not? Yeah.
You could replace that and check if you want.
True, I could actually.
But you should subtract the second by the
Second minus first.
Yeah, true.
No, first.
No, you can do it either way.
It's the same thing. It's literally the same thing.
Same outcome, yeah. You can do second minus first. Expand your mind. You don't have to do first minus second. Are you sure? Okay. Is this okay?
Yeah.
Right. Next now. Can I remove these examples?
Yes.
Yeah. Okay. So next now we want to have a look at another formula, which is the sum. Yeah. So this symbol here, Sn. Listen, guys, listen. This symbol here, Sn, means the sum of the first n terms. So, for example, S3 would mean the first plus the second plus the third. S4 would be the first 4, and so on. Okay? And we want to figure out, is there a formula for this? And of course there is. So, let's just write down the first few terms here. Now, guys, there's too much background talking while I'm talking now, please. Okay, are we listening? Yes? So, let's work it out. The first term is A. The second term is A plus D. The next one is A plus 2D. And then this continues all the way up until the last term, which is A plus n minus 1D. Now, obviously, this formula is not the formula we need, because it's not very useful. It just says Sn is the first plus the second plus the third, which it is. But what we want to do is to try and simplify this, compact it into a smaller formula. Okay. So there is a little trick to this. I wonder if anyone remembers how to get the proof of this formula. Does anybody remember this one from school? No. How to simplify this?
They're all 1 minus.
I know that's the answer. I want to know how to get there.
As the first and last.
Yeah, that's it, yeah. So what we do is we write this out again, except we just write it backwards. So rather than saying Sn is the first plus the second plus the third, it's the same thing. We'll just say it's the last one. So that's that one there. I'm literally just writing everything backwards. Plus dot 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 plus a plus 2d plus a plus d plus a. So I just write everything out again, except I just put it backwards. Like that. Yeah? Now you might say, what's the advantage of that? Well, this is where the trick part comes into it. Now what we do is we add the two lines together. Now if we add the two lines together, let's see what happens. So if I add the first guy here with the first guy here, what do I get? Get 2a, okay. Right, well now think about what we get for the next one. If I do a plus, let's see, now we can't quite see the next one here. What's the one after this one? Oh sorry, I missed out 2a plus n minus 1d. Yeah, it's a little bit hard to see, because if I had colours I could highlight it in colours here. So if you want to use a colour pen to highlight, this is the first one here, and this is the first one here.
Why isn't it a and minus 1d?
No, this is right. First one was the first one. Can you see that? Yeah, so like you have an a here, you have an a here, and an n minus 1d here. So you get 2 a's plus n minus 1d. Okay, now let's just jump to the last one. Okay, so let's add the last one and the last one together. So what happens if I add this last one here with this last one here? It's the same, isn't it? There's 2 a's and there's an n minus 1d as well. So you get another one of these guys. Yes, you can see that. That's what happens when you get the last and last. And you won't be surprised to know that you get the same thing every time you add the two together. So the first one plus the first one will make that. The second and the second will make the same thing. The last and the last will make the same thing. You keep getting 2a plus n minus 1d. Oh, and of course here I should have a 2, because I added the left and the right together. So on the left I have s and s makes 2s. And on the right, everything is the same. Now, how many of these guys do I have? I'll put in square brackets to help you see. So how many of these guys here do I have? Well, I wrote down 2, but yeah, how many altogether, if you think about it? N of them. What? I have N of them, yeah. So what's one way to simplify when you're adding the same thing to itself n times? Not square. Not square. No. Multiply. Yeah, multiply. You know, if I had 2 plus 2 plus 2, that's the same thing as 3 2's. You know, so if I have this n times, what can I do? Well, I can just say it's n times one of them. I don't need to write it out n times. And this is how the simplification happens. So let's clean that up. So I have n of them. Focus here now. Okay. So can you see that? I just multiplied by n now. Because I have n of them, the same. Right, there's only actually one thing left to do. And then I've figured out a nice small formula for Sn. Not expand, no, because I'm trying to keep it compact. Divided by 2. So if I divide by 2 now, Oh, come on. Now, this might give you a formula that some of you actually recognize from school. N over 2, 2a plus n minus 1d. This is you haven't seen this one? Some people might, there's some other ways of writing it, like n over 2 times first term plus last term.
Yeah, that's better.
Yeah, it's the exact same thing as this.
Absolutely.
No? Okay. You haven't seen this before? Are you sure?
Same here.
This was in C1.
No, those people... Yes. There is another way to write this formula. It's n over 2 first term plus last term. Yeah, that's exactly the same as this.
Yeah, A1 plus
an. Yeah. It's the same thing as this.
Yeah, we're used to that one.
Okay, well, life brings many changes, and this is one of them, okay? So if you can write the formula down like this. Well, write it down. Okay. Now, most importantly, let's have a look at some examples with this now. And really, I want to show you that this really does work, so I'm just going to actually open up Excel here. Now, I'll have 4 programs open at the same time, so hopefully this won't crash it. Huh? A gig. One. Oh, yeah, a whole gig.
One? There are calculators that have more.
Yeah. It's a gaming machine. You know. Right, let's have a look at an example here. So, can I delete all of this? Yes, can I delete this? It's going? Okay. What example number am I on now?
5.
Example 5, okay. So, calculate, and we'll say, what is it now? I'll do that one here in the book. 8 plus 11 plus 14 plus all the way up to 125. Right, so I want you to calculate this sum for me. Oh, and also actually, I was a little bit nice in this one. I also tell you how many terms there are. So I don't write them all down, but I tell you that there are 40 numbers here I want you to add. 8, 11, 14, all the way up until you get to 125. So we can use the formula we just figured out. Good. What's the A? 8. And what's the D? 3. Good. And the M? 40. Because it's the number of terms you have. So using the formula you just wrote down, calculate the sum here. So go ahead and calculate, and then we can check if it's right. I think I have my formula correct. Is that it? N over 2 times 2a plus n minus 1 times d. Yeah? Question? No? Is this okay? What does that end up equaling when you work it out there? 2,660. Now, like I said, I want to show you that this really does work. So if I just go to Excel for a moment here. So my first number was at 8, and then my next one was 11. And I stopped when I got to 40 terms, which is... So there are the first 40 numbers, okay? let's see what happens when I add them all up. Yeah. Sum of all of these. So add all these 40 numbers together, and there it is. 2660. So it works. The formula provides a quick way to add many numbers together. Yeah. So you can quickly add as many, it doesn't matter. 40, 100, 1,000, doesn't matter.
Could they not give us M?
Yeah, that's what I'm going to do next now, I think. Yes. That one is example 7. You're right, because it's a little bit harder now if they don't. You have to figure it out. Yeah. Okay. Can I, oh sorry, you might need to write that down. Can I remove this example? One sec, okay.
What if we did the second formula?
What do you mean? First plus last? Yes.
What?
Yes? Yes? So if you did the second formula, first plus last would be 8 plus 125. So 133, is it? And then it's multiplied by 20. Yeah. You see, there needs to be more trust in me. Huh?
Does it do that 8 plus n minus 1b is equal to 8 plus n?
Yes. Yes. So when I said earlier, it is exactly the same thing. I wasn't lying. It is exactly the same thing. Yeah. I'm not feeling the trust here. I'm not feeling the trust.
I'm just very, very, very confused.
Question then?
No, the thing is that I don't have a specific question. I'm just confused.
Okay, we'll just try to concentrate then. Okay, next example. Next example. Next. Okay, so example 6 then. Yeah, in this one here, I don't tell you the n, and I want you to write your answer in terms of n. So it's calculate 5 plus 13 plus 21, etc., etc., etc. So there's no n here. I just want you to figure out a general formula. But that's okay, you have the formula you can use. So let's have a look at this. Okay, so let's write this down. It's Sn equals n over 2. So in this case, what's the n? We don't know. And then it's 2a. What's 2a here? 5 times 2. So it's 10 plus n minus 1, which we don't know. And what's the d? The 8? Yeah. So what I've done is I've just put in the things that I do know, and then I just clean it up a little bit. That's all. So, okay, we'll expand in the middle here.
If you give us the last term, can't we just find the n?
Well, I don't give you the last term. I just give you the first 3. So what do I get inside the brackets? I get 10 plus 8n minus 8, yeah? So obviously 10 minus 8, 2.
Divide by 2.
Yeah, can I simplify any more?
Yes.
Yeah, what can I do?
It's going to be 4n plus 1.
Cancel the 2.
Yeah.
4 and 4 plus
N. Or we can just do n squared.
2n, oh sorry, typo, should be a 4. 2n, typo again.
What?
And 1n, 1n, because I cancel above and below by 2. Yeah, so n plus 4n squared. Because this 2 and this 8, you divide it by 2, you get 1 and 4. Right?
Yep. Can I do a 153 or is it wrong?
Or is there... Is this right?
Yep.
Are you sure?
Yes.
You can just remove the n and do it on the calculator. It gives you the same.
Yeah. Let's check that this is right. So if this is supposed to be my formula, what should I get if I just add the first term? Well, I should just get 5. So if I put n as 1 in this, do I get 5? Yes. Now if I add the first two numbers together, what's a 5 and a 13? 18. So if n is 2, what do I get here? 2 squared is 4 times 4 is 16 plus 2 is 18. It works. 5 plus 13 plus 21. That would be whatever you get when n is 3. I'm sure of it. I'm confident of it. So 5 and 13 is 18, isn't it? 18, 28, 39, is it?
Yep.
Yeah, and if you put n is 3, 4 times 39. Yeah, say whatever. It'll work. It'll work. So this is the formula for adding up as many as you like. It doesn't matter. So if I said add up the first 100 numbers, all you have to do, put n as 100, and that's it. Okay. So very useful. They sometimes ask you to do this in the exam. What they would normally say is write this in terms of n, because then in the next part of the question they would say something like, you know, add up the 100 terms or something like this. Yeah.
How do you get from the before the last to the last?
The second last to last. Yeah. So what I did, this is a 2 and an 8, and I divide that by 2. So that's a 1 and a 4 now, because it's over 2. And then if that's a 1 and a 4, and I multiply by n times 1 is n. And n times 4n squared. Yeah.
So you can't go for it.
Huh?
You can't go for it.
No, it's the simplest form now.
So isn't there any formula we could use to get the last term?
No, because I didn't provide the last term.
Like, is there any formula we could?
Well, the next example we're going to do is maybe like this. Yeah, example 7. Okay, did you write this down? Yeah, you have this? Oh, come on. Guys, there's lots of background chatter now. Come on, I need you to focus on this. So next one, example 7. So this time I do provide you with a final term. So I'd say calculate minus 8 minus 11 minus 14 ... minus 113. So in this one here, I want you to add them all up, and I do provide you with a final term now. So the very first thing I should do is work out what the n is, how many terms I have. And we did an example of that earlier. I have to use my first formula, the UN formula. Okay, so using that formula, I get minus 113 equals. Okay, so for this sequence, what is the A? Minus 8. And the D? And I have my final term. So it should be no problem to work out the n. So I want you to calculate the n for me. N is 36, is it?
No, sure.
I can check. No, I'm using the UN formula first. Yeah. What do we get for n here? 36, correct. You've gotten the S part now, is it? Yeah, so use A equals minus 8 and D equals minus 3 and N equals 36 into the S formula. So, can you type that into the S formula? What would it be? N over 2, which would be 36 over 2, 2A plus N minus 1, which is 35, I think, times d, which is minus 3, isn't it? Do I have that all incorrect? Let's see. N over 2, 2a plus n minus 1d. Yeah, looks okay. Got that? So what is that? If somebody's typed that in for me, please. What did you get here? Minus 2178. Great, okay, so you can write this example down. That's the switch to maths mode. So anything that has a dollar sign around it is, you're telling the program it's a formula or a number or a power or something like that.
And what language is it?
There it is, LaTeX. Okay. Did we write this example down? Yeah, next example. Example 8. Okay, example 8. Right. The sum of the first 19 and 22 terms are 228 and 2 are, what did I say? 228 and 297. So, you can probably guess what I'm going to ask here. I'm going to ask for the A and the D. So I tell you, if you add up the first 19 numbers, you get 228. If you add up the first 22 numbers, you get 297. What's the A and what's the D? Okay, so what should I do first here? Yeah, put it into the formula. So let's have a look. Good, yeah, okay, let's write it down. 228 equals 19 over 2. Yeah. And then 2a plus 18 times d. Is that right? N over 2, 2a plus n minus 1d. That's the first one. Yes? Second one, okay. We're not quite there yet. Right, second one. 297 equals 22 over 2, 2a plus 21d. Actually, I put in an extra new line here so you can... Right, can you read that okay? I'll put in a bit more space for you. So I've made two equations. So I think it's pretty obvious what to do next. Yeah. Elimination, but even maybe before elimination, what should I do first? I think what I'll do, yeah, I'll multiply by 2 and then divide by 19 and divide by 22. Guys, are we listening? Listen. Listen. Bring the 2 up here and the 19 down. Bring the 2 up here and the 22 down. This will just make it a little bit simpler. So just on your calculators, just type in 228 times 2 and then divide it by 19 and tell me what you get. So 228 times 2 divided by 19. 24. So I can simplify this equation down into 24 equals. If I just bring the 2 up and the 19 down. Now what should I do with the second one? I'll do the same thing. I'll bring the 2 up and the 22 down. So what's 297 times 2 divided by 22? Is it 27? Well no, I wanted it like this. Because now what's my advantage here? Yeah, what can I easily eliminate?
A.
The 2a. By subtracting second minus first. Agreed? Yes. So, let's do that. Thank you.
How did you use, what gave you the mathematical right to just define like that?
Mathematical right. I can do whatever I like. As long as I do it legitimately. So, I'm allowed to bring the 2 up from the right to the left.
I thought you divided this by 19, right?
No. I brought the 2 up and the other thing down.
2 up?
Yeah, and the other number down. Dude. This is why, when you're talking, I know you're not listening. The 2 up and the 19 down. Right. Now, dude, okay. Listen. Get the 2 girls at the back listening, please. I'm getting tired talking over people, so the next time I have to stop because somebody is chattering in the background, I'll simply ask them to leave, because it's distracting me too much now. So I need you listening here. So I'll do second minus first. So 27 minus 24, 3. Fine. Then 2a minus 2a, both cancel. 21d minus 18d, 3d. So can we easily get the d here? Yeah. Easy peasy, I have the d. D is 1, and I can sub it back in to get the a. So d is 1 and a is 3, you say? Which is put into the first equation. Yeah. Yeah, so that's fine. Okay, I have one more example to do. Yeah.
So would you sub it in back to the fraction equation, or you can use it for the circle?
Actually, you can use anyone. Anyone, yeah. Yeah.
What's the time?
Time 47. After the next example. What, can you wait one more example? Yes? Okay. Okay, so let's continue now. Continue now. I need to continue now. Dudes, I need to continue. Right, so next example. Example 9. The following are in arithmetic progression. So, I'm going to give you 3 terms, and the only thing you know about them is that they're arithmetic. So the first term is 2 plus 9x. The second term is 3 minus 4x. And the last term is minus 4 plus 6x. So, you have 3 terms, and they're all arithmetic. So what does that tell me about their relationship? Well, it means that there's common difference between them. So how can I use that fact to get something useful here? The fact that I know that these are in arithmetic progression.
You can apply the formula and compare.
Not the formula and not adding them. Not quite adding them. Subtracting them. Yeah. Because if you think about it, like suppose I have some sequence like, let's just say 6, 10, 14. To find the d, yeah. So like look here.
3 minus 4.
Oh, sorry.
Do we know that they're in sequence? Like that's the first, that's the second, that's the third?
Yeah. No. When you would say arithmetic progression, that would be implied. Yeah. It's sequential. Right. So look here. This sequence example is arithmetic. Okay. You notice that if I do 10 minus 6, what do I get? 4. If I do 14 minus 10, I get 4. So the point is, if I was to do the second minus the first, that should be the same number as the third minus the second. So that's the key concept here. Because they're in arithmetic progression, I can say the difference between the first and the second should be the same as the difference between the second and the third. So let's see what equation we can make here. Okay, so let me just write that down. So it'll be something minus something equals something minus something. Okay, so it'll be something 3 minus 4x, 2 plus 9x, and then here minus 4 plus 6x, and then 3 minus 4x. Okay, so I was able to make this equation. Second minus first equals third minus second. What type of equation is this? Linear, quadratic, cubic, what type is it? It's linear. So this, no problems. I'm not even going to bother to solve this because it's the easiest type of equation to solve. Just group the x's together and bring the numbers to the right. Simple. And you work out the x. The only thing to do at the end is after you get the x, sub it back into the original sequence so you can figure out what the first, second and third term is. So whatever the x is, just put it back in to the question to get the first, second and third term. Yeah? You time for your water? Yes. Take a 2-minute water break. Go. Because there's 9 questions here, we'll just say do the last question in each. The last one in each. Okay. Yeah. You can start now or get a cup of water, your choice. Or that's possible too. Yes. Is it possible? It is possible. Yes.